This is Review 3 in College Algebra, page 17, addition, subtraction, and multiplication of polynomials. And if you look on page 17, they give you some information, some vocabulary for algebra. One of the things they tell you is polynomial, and basically a polynomial is when you have more than one term, and the term is determined by a plus and minus sign. So right there I have 3 terms, and that is a polynomial because poly means many. Coefficients is another term that we're talking about, and a coefficient is the number that is in front of the variable there. And we also have a leading coefficient. The leading coefficient is generally the first coefficient. And what we normally do, let me erase this here. What we normally do is when we write polynomials down, we write them in descending order. So for example, I would have 2x to the 4th minus 3x cubed plus 2x squared minus 6. And that right there would be my leading term, which means that this right here would be my lead coefficient. Okay, my constant term would be this one, generally the last one, and the degree of the polynomial of the whole thing is going to be the highest term here. Alright, so we're in descending order. The degree of the polynomial is 4. My constant term is -6. My lead coefficient is 2, and that gives you the definitions there on page 17. Alright, so gonna jump to the next page, page 18, and we're talking about polynomials in several variables, and all that means is if we have something like 5x to the 4th plus y squared plus z, that's a polynomial in several variables. And the degree of a term is the sum of the exponents of the variables in that term. So for example, if I have 7a squared b to the 3rd, the degree of that term is 5 because we add up our 2 and our 3 on that on the a and the b, and that gives us the degree of the polynomial. Alright, jump down there to addition and subtraction, and most of you remember that when you have addition and subtraction, the only thing that you can actually add and subtract are like terms, and like terms are always those terms that have the same variable and the same exponents on those variables. So in this particular expression here, when we're adding these, the only thing that we can really do is we can combine this one with this one, since they both have x's and the x's are cubed. We can combine those, and that's it. So when we combine these two together, obviously we're going to get 7. And when we combine this one and this one, we're going to get minus 4x squared. We're going to get a negative x plus 3. And that will be our answer after we combine like terms. So, not really anything too difficult. Multiplication, on the other hand, is so much nicer because multiplication, you can get rid of everything, or you can multiply everything, and that makes it nice. There's no real rule as far as like terms or anything like that. So I'm assuming that you know the whole multiplication thing. I'm not going to spend any time over it. We've done the FOIL method, so you know that. And middle of page 20, special products of binomials. And they're just telling you, what are you going to do when you get a problem like x plus y, the quantity squared. Well, we're going to square the first term, square the last term, multiply the two terms together for the middle term, and double it. And that's what we're going to get there. And if we were to do a minus, if this were x minus y, the quantity squared, Rule is the same. Square the first term, square the second term, write the xy, double it, but there's going to be a minus sign there because of this here. It's going to give us minus 2. Then when we have an x plus y times an x minus y, that's actually the answer to the difference of two squares. And so we're going to get that. It is not equal to that because we just did that there. Okay, so that's pretty much it for review of section 3.